class, we're about to start lesson 3, scientific notation. Now, one thing that you need to know about scientific notation is that it is typically used to write very small or very large numbers, trying to condense those values. Now, what I'm going to do when I deal with scientific notation, I'm going to go through the exercises instead of giving you a lot of definitions so that you can see how it actually works. But one thing I do want to point out to you is a pattern here with scientific notation. First of all, if you look at example 1, scientific notation is written in this form. It must have one digit in front of the decimal, and that digit can only be digits from 1 to 9. It cannot be any digit less than 1. It cannot be any digit greater than 9. So if you're looking at something that says it's scientific notation, if it doesn't have one digit in front of the decimal, that's 1 to 9, it is not scientific notation. And it's always multiplied by 10 to some power, either a positive power or a negative power. And we would get into how a positive or negative power affects the scientific notation. Now up here, when we look at the multiples of 10, we're looking here at 10 to the first, 10 to the second, 10 to the third, and so on. As you increase your positive exponent by 1, you notice that it keeps adding a 0. That's the pattern. And then when you do negative, if you notice behind the decimal, it keeps adding a 0 in front of the 1, and that's behind the decimal. So it went down from negative 1 to negative 2, so you added a 0. Went down to negative 3, you add another 0. Went down negative 4, you add another 0. So basically, when you look at this problem, what you see here, whenever you're doing scientific notation and multiplying by 10 to a positive exponent, that means you're getting into larger numbers than if you're multiplying by 10 to a negative exponent. So now, we're going to go down here and actually go through these problems. And I'm going to take you through this step by step, and we're going to go through every single problem on this page, which goes up to problem 23. So problem number 1, it says write each number in scientific notation. So we have 2300. This 2300 is considered to be in standard notation. Whenever you have a whole number in standard notation, you find the decimal, and we know that the decimal is, after we designate our decimal, we have to move it to get that one digit in front of the decimal. That's 1 through 9. So we move 1, 2, 3. So we have 2. That 2 falls in the 1 through 9. So this is rewritten as 2.3. We don't have to write those excess zeros. So this will become 2.3, then it's times 10. Now to determine the exponent, when you take a whole number and write it as scientific notation, your exponent is going to be positive. So we moved it 1, 2, 3 places, so it'll be to the third power. So your answer here for number 1 would be 2.3 times 10 to the third power. Okay, problem number 2. We would have, and I think I need to move this up just a little bit. Yes. Problem number 2. We would have 0.00042, and we want to rewrite this as scientific notation. So we move this decimal 1, 2, 3, 4 places to the right. So now we have 4.2, because again, we have to get one digit in front of the decimal. That's a number from 1 through 9. So that'll be 4.2 times 10. Now, whenever you start off with a decimal, a number that's not a whole number, or starts off with a 0 in front of the decimal, your exponent is going to be negative. Or you could say if you move the decimal to the right, your exponent is going to be negative. It's going to be 1, 2, 3, 4. So it'll be negative 4. Now, if you notice, the amount of places you move does not change. You move 4 is 4, but depending on which direction you're going will determine what the sign of the exponent is. So now we go to number 3. We had 12,400,000. So we put that decimal at the end. We moved it 1, 2, 3, 4, 5, 6, 7 places. So it'd be 1.24 times 10. And since we start off with a whole number, it'll be positive 7. Or you move to the left. That makes your exponent positive. So problem number 4. We have 14,320,000,000. Put that decimal at the end. We move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 1.432 times 10 to the 10th power. Now again, we don't have to write the excess zeros, but we must write all of the numbers that does not include the zeros. So number 5, we had 36 million. Put the decimal at the end. We have 1, 2, 3, 4, 5, 6, 7. So it'd be 3.6 times 10 to the 7th power. Okay, number 6. We have 0.0095. Move this decimal, we go 1, 2, 3 places. So it's 9.5 times 10. We move 3 places to the right, so it'll be a negative exponent to the negative 3 power. Okay, number 7. We have 0. Now we count how many zeros we have. 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6, and then 5, 8. We move this decimal 1, 2, 3, 4, 5, 6, 7 places. So it's 5.8 times 10 to the negative 7. Now number 8. We have 150 billion. So that'll give us 9 more zeros. So now we find that decimal at the end. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that'll give us 1.5 times 10 to the 11th power. Because remember, we moved to the left. So now we go here to problem number 9. We have 0. We count how many zeros we have here. 1, 2, 3, 4, 5, 6, 7, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8 zeros. Then the number 9 equals, we move this decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So it's 9.0 times 10 to the negative 9. Okay, now we move on to problem number 10. Problem number 10, it said convert from scientific notation to standard notation. So we have 5.173 times 10 to the negative 4 power. Okay, so now we want to take this 5.173 and we have to move this decimal 4 places to the left. I actually didn't give myself enough room, but we move it 4 places. 1, 2, 3, 4 places. So our answer here would be 0.000517 and that is your final answer. But in the next problem, I would definitely give myself enough room. Number 11, 3.7 times 10 to the 6th power. So we'll take 3.7, we'll move this decimal 6 places. 1, 2, 3, 4, 5, 6. So that'll give us 3, 7, and 5 zeros. So this will give us 3,700,000. So now we move to problem number 12. 4.8 times 10 to the 8th. So we have 4.8. Move 8 places. 1, 2, 3, 4, 5, 6, 7, 8. So we have 4, 8, and then 7 zeros. So it'd be 480 million. So now we go to 13. We have 1.7 times 10 to the negative 5. So we'll take our 1.7 and we'll move 5 places to the left. 1, 2, 3, 4, 5. So it'd be 0. We'll put 4 zeros, and then we'll put 1, 7. Problem 14. 7.2 times 10 to the negative 3. We have 7.2. Move our decimal places 3 places. 1, 2, 3. 3 places to the left since it's negative. So it'd be 0.2072. Problem 15. We had 9.16 times 10 to the 5th power. So we had 9.16. Move this decimal 5 places to the right. You got 1, 2, 3, 4, 5. So it'd be 916 and then 3 zeros. So it'd be 916,000. So problem 16. We had 8.591 times 10 to the 7th power. So 8.591 times 10 to the 7th power, we'll move this decimal 7 places. 1, 2, 3, 4, 5, 6, 7. So it'd be 8591 and then 4 zeros. So it'd be 85,910,000. So problem 17. So we had 9.56 times 10 to the negative 6th power. So we had 9.56. Move this decimal 6 places. We got 1, 2, 3, 4, 5, 6. So it'd be 0. We'll put 5 zeros and then 956. Now we move on to problem 18. Problem 18, it says answer the following questions. Many domestic satellites maintain an orbit approximately 23,500 miles above Earth. What is that distance in miles in scientific notation? So we'll take the 23,500 and we want to change this to scientific notation. So we'll take our decimal here, we move it 1, 2, 3, 4 places. So it's 2.35 times 10 to the 4th power, because we moved it to the left 4 places, and then we'll write the word miles. That's it for problem 18. Now we go to problem 19. Problem 19, it says modern technology measures very fast transactions in nanoseconds. 1 nanosecond is equal to 1.0 times 10 to the negative 9 of a second. How many seconds is a nanosecond in standard notation? So we'll take 1.0 times 10 to the negative 9. So that means we would take this 1.0 and move this decimal 9 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'll be 0. Then we'll do 8 zeros. And then 1. Now we don't have to write the 0 behind the 1. So it'll be 0.8 zeros 1. And then we'll write nanoseconds. So it'd be nanoseconds. So then 20. It says the average distance of Neptune from Earth is 2.67 times 10 to the 9th miles. Write the distance in miles in standard notation. So it's 2.67 times 10 to the 9th. So we'll do 2.67 and move this 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'll be 267 and 7 zeros. And then we will put miles. So it'll be basically 2,670,000,000 miles. Okay, 21. It says light in the vacuum of space travels at a speed nearly 300 million meters per second. Write the speed in meters in scientific notation. So it's 300 million. We need to write that out first. We got our decimal here. We move 1, 2, 3, 4, 5, 6, 7, 8 places. So that would give us 3.0 times 10 to the 8. And of course, that's meters. All right. All right, now we go here to problem 22. We scroll down. It says choose the one best answer to each question. Questions 22 and 23 refer to the following table. It says, what is the number of square feet in an acre written in scientific notation? Now, first of all, if we look at answers for A and D, those two are disqualified because remember, I told you, with scientific notation, in front of the decimal, it can only have the digits 1 through 9. So this has 0 and this has 43. So both of those are disqualified. So now we look at 1 acre, which is 43,560 square feet. Okay? So we put the decimal here at the end. We go 1, 2, 3. It goes 4 decimal places. So that's 4.356 times 10 to the 4th. Now the one that matches this is B. So B is your answer. Now problem 23. It says a shipment of goods weighs 5 tons. Which of the following expressions could be used to express the weight in metric tons? Okay, first of all, we're dealing with this 0.907. So now we want 5 of those. So it's 5 times this value here. But remember, with scientific notation, we have to move this decimal 1 place to the right to get 1 digit in front of it. So this would end up being, with problem 23, we'll take our 0.907, move this 1 decimal place to the right. It'll be 9.07 times 10 to the negative 1 because we move 1 to the right. So now we have to do 5 times this value here. And the only one that expresses that is D. So it's 5 times 9.07 times 10 to the negative 1 power. So it's 5 times 9.07 times 10 to the negative 1 power, which is D. And that is problem 23. And we are done with this lesson 3, and I will put this up on YouTube. Have a wonderful day.